Welcome back, everybody. Due to the length of the previous video, I decided to do OSPF version 3 on its own video, just so that you'd be able to jump right into the configuration rather than waiting half an hour, 45 minutes for me to get to the point. So we're going to go ahead and enable OSPF version 3 on the same connections that we did for OSPF version 2 on routers 3, 4, and 5 for area 0. And then go from there. I'm not going to go through the extensive breakdown for the adjacency and stuff like that, and breaking down the SPF and RIB installation methods and processes, because they're the same for OSPF version 3. I'm just going to show you how to get those working and get them up and running. So from our configuration standpoint, we're going to go ahead and pull up our topology, and we're going to go ahead and on R5, we're going to start on him. We're going to go to global config, interface fastest at 0/0.100, and type in OSPF version 3, the process ID of 1, the address family that we want to work with. In this particular case, it's going to be IPv6, and then the area you want to put it in. That's really it. So we're going to type in this guy right here, and jump over to routers 4, and interface fastest at 0/0.100. Right click and paste. OSPF, okay, IPv6 unicast routing. And then on 3, the same thing. So exit out, IPv6 unicast routing, interface fastest at 0/0.100, and 100, and voila. Now I'm going to go ahead and on interface loopback 0, also enable it there. On 4, interface loopback 0, and on 5, interface loopback 0. There we go. So now we should show OSPFv3 1 neighbors. They are an X start. So momentarily we should get the adjacency up and running. There it goes. 4 is up, and now 5 should be up here momentarily. Or I'm sorry, 3 should be up, and there it goes. So now we have it. So now that I've enabled OSPF version 3 on those interfaces, all of your show commands are show OSPFv3 and the same outputs. So everything I showed you in version 2 in the previous video, you would do in this here as well. You can get more specific, like IPv6, and specify the interface brief and who you got running where and the address family it's running for, stuff like that. Everything else is the same. The one thing that's different about the outputs, we do a show IP OSPF question mark. You'll notice that at the very end here, down where it says virtual links, versus this guy right here, show OSPF version 3 1. Come down here at the bottom of OSPF version 3, you have VRF. Now that's why I pointed out to you the VRF aware process versus the global aware process. So if you've got OSPF version 3 and OSPF version 2 process ID 1 in the global table, and you want to put OSPF version 2 and you want to spin up a VRF aware process, it has to be a different process, and you would specify the process in the output. So if I had a VRF, which in this particular case I actually do have a VRF, show VRF, I've got 2 of them. If I did a show, I don't actually have OSPF running for it, but if I came in here and I was to go to global config and type in router OSPF 2 VRF dynamic and jump out of here and do a show OSPF IP OSPF 2 question mark, I'd be able to hit the enter key, and then it would show me OSPF version 2, but it's the VRF aware process. That's how this process would come into play. So if I did this for 1, it would be a different output. So based off of that, I wanted you guys to understand that piece. Now, one major thing that you're going to see between the VRF aware process versus the global process is with the VRF aware process, it says connected to MPLS VPN super backbone. Down here, and this is right above event log disabled. We have event log disabled, or event log enabled. Right here, would be in between support NSSA compatible with RFC 3101 and the event log enabled. You don't have the connected to the MPLS VPN super backbone. The reason why this guy shows up here is because when you enable VRF Lite on an OSPF customer edge router, the OSPF will receive from the PE router running OSPF, will turn the down bit on, and the CE router will receive that, and it won't be able to propagate the route and inject it into the routing table. We'll talk about that when we get into CCIE and CCNP service provider and CCIE service provider and why that's important. They call it multi-VRF CE with OSPF, and it is a loop prevention technique. So we'll talk about that more in detail later, but I wanted to point that out since I was sitting right here. We're not going to be using OSPF as a PE to CE routing protocol when we study MPLS. We'll be using strictly BGP, but that's basically how you would break that down. So that's how you would verify that. If I do a show IPv6 route OSPF, I have two routes. I have 2001:3 and 2001:4, which is the loopbacks to router 3 and router 4 respectively. Now here's the thing. When you're looking at this output, you don't know who this is. That's the layer 2 address injected into the link local address. So the link local address is this guy right here, this FE80 address. It's really, really hard to understand who that might be. Unless you know the MAC address, the last few digits of the MAC address of that interface, you're not going to know who that is. So to change that, on router 5, I'm going to do this. I'm going to type in interface fast Ethernet 0/0.100, and I'm going to type in IPv6 address is going to be FE80:5 link local. Okay, I do that. Now you'll see that the adjacencies go down because I changed the next hop information, and the adjacencies will come back up here in just a moment. I changed the IPv6 address, and I'll go ahead and change that on 3 and 4 as well. Interface fast Ethernet 0/0.100. IPv6 address is FE80:3 link local. And on router 4, I'll just make this .4. So router 5 should have adjacencies back to these guys, and he does. And what ends up happening here is because of the fact that you change the next hop information, you need to make sure that, or you change the subnet on it, and so that had to be changed. So if we do a show OSPFv3 1 neighbors, now we are peered. But if we do a do that show IPv6 route OSPF, now we get, and it actually hasn't updated yet for router 4. Not sure why. Router 5. It should eventually. Oh, there it goes. It hadn't come up yet. There we go. It makes it easier to identify the router this way, because now it says 3 and 4. Okay, well I know who that is then. I know who router 3 and router 4 is. You could tell by the route, but if you get a really long routing table with lots and lots of routes, it makes it that much more difficult for you to determine who it is, because the routing table can get kind of skewed and look really, really big. So it's important to understand how that piece comes into play. Now, the cool thing is, when you're looking at this and breaking it down, it makes it a lot easier to interpret what it's trying to say. That's really why you do that. It's no, it is not a it's not going to improve reachability. It's not going to speed up convergence. It simply makes it easier for you to identify who you're connected to. So you can do that. That's one way to do it. Beyond that, guys, that's pretty much it for that particular piece of it. So let's just verify that we have reachability. We're going to ping 2001:3 sourcing off of loopback 0, and I can ping it all day long. And that's a good sign. If I can't ping, there's a problem, and I would have to go dig into that. But at this point in time, everything looks pretty good. There's really not a whole lot going on here that we really need to dig into beyond what we've already covered. So that's really what I wanted to break down in regards to how the configuration is put together. Now, there is a way globally to modify the OSPF version 3 process globally. So router OSPF version 3.1, and then if you were to come under here, you can do several things. You can go in here and mess with, the address family, the auto cost reference bandwidth. You can enable BFD. You can set the max metric GRED or LSA. You can do prefix suppression, passive interface. You can pretty much, and we'll cover quite a few of these as we're going forward. The same thing can be done with router OSPF version 2. So there's a lot of options under here. There's even more so than version 3. And there's a lot of stuff that we're going to take a look at as we get into this. We're going to cover, I'd say, a good 70% of what you see here. And whatever we don't cover here will be covered in CCIE and broken down. Again, most of this stuff isn't very difficult. It really isn't. It's just a matter of understanding where you would use the different commands and why you would use the different commands. Beyond that, guys, that's pretty much it for this video. Thanks for stopping by, and we'll catch you in the next video.